All right, now let's actually look at an example of a redox reaction and use what we learned about oxidation number. All right, is this reaction a redox reaction? If so, which element in the reaction is oxidized and which element is reduced? Right, we know that oxidation, right, oil rig, oxidation is what? Loss of electrons. And reduction is gain of electrons. So when it's asked which one is oxidized, we're trying to look at which one lost electron and which one gained electron in the reaction. All right, let's see. Okay, in this case, we have to first assign oxidation number for each atom. We saw that H usually has +1 charge, right? And N, since this is +3, N has to be -3 because it has to equal 0, right? Okay, how about O2? O2, we saw in the rule that since it's not combined with other compounds, it's basically a diatomic element or diatomic compound like that. And we know that in these cases, since it's a covalent bond and it's not really a compound because it's only bonded to itself, right? So in this case, it's going to be 0, right? Only when it's combined with other elements, O has a -2 charge, which is right here. O would be -2 in this case because it's combined with N, and N would be +2. Same with H2O. It would be -2, and H would be +1, and it would all equal to 0 because there are 2H. Okay, now if you look at here, let's compare H, right? H started with, so we're going to look at the reactant side, right? H started with +1, and still in the product side, it's still +1, right? And how about N? N started with -3, right? It had an oxidation number of -3, but on the product side, it has +2, right? So, its oxidation number changed. What about O2? What about oxygen? It started with 0, and it became -2. Okay, now from -3, in order to become +2, it became less negative, right? So it basically lost electron because it became more positive. But oxygen, because it became more negative, it means it gained electron. Okay, because the charge become -2, that means it gained 2 electrons because electrons are negatively charged. So in this case, by comparing the charge before and after, we can know which one lost electron and which one gained electron. So in this case, oxygen was reduced because it gained electron, and nitrogen was oxidized because it lost electron. It became a more positive oxidation state. All right, let's do another example here.
Group together.
If you look at this one, I want you to, I know this is a lot, but I want you to try. Find the oxidation state for each atom and then compare before and after to see which one is reduced and which one is oxidized. All right, go ahead and pause and try it. Okay, let's go. All right, here we have 6I minus. Now remember, this 6 is saying basically we have 6i minuses, right? So it's not like there are 6i and it's not where there's 6i and in total they have -1 charge. It's not like that. It's saying each I is -1 charged and there are 6 of them. So individually, I would have -1, right? O4. Again, O is usually -2. So since there are 4 of them, it's going to be 4, that's -8. And since it has to equal -1, Mn must be +7. Right, H2O, -2, and this should be +1. So here now we're on the product side. Since this I2 is going to be 0, O2 usually it's um, -2, and it's going to be +4. And O is -2. H must be +1 because it has to equal -1. All right. Since MnO2, right? I know you might have thought that it is a peroxide, but in this case, it's not a peroxide. Right? Peroxide usually it has 2 like that, but in this case, it was just simply Mn1 and O2. So this one is -2. Okay. Right. So we have to compare before and after, right? Let's look at I. It became more positive, right? But from -1, it became oxidation state of 0. So it must have lost electron because it became more positive. Okay, how about Mn? From +7 to +4. Now it didn't become a negative number, but it's still, the oxidation number got smaller. It became less positive, which meant there was a reduction of -3 in the charge. So this means that it gained electrons, right? It gained 3 electrons, basically. All right, let's look at oxygen. On the left side, oxygen is both -2, right? On the right side, it was both -2. So they're the same. Let me do that with a different color. I'll just do it on blue or pink. -2, they're the same. How about hydrogen? Hydrogen as well. It was +1. On the product side, it was still +1. All right, so Mn was, since it gained electron, it was reduced. And I was oxidized. Okay, so that's it for identifying which one was oxidized and which one was reduced.